to address the question of ontology. And the conference that Harald and Philipp organized last year in Linköping on QBism and phenomenology was very much focused on that particular question. Okay. And then the third plank is the third of the three interlocking projects is the reconstruction of the quantum formalism. And it's very well known that the QBist way of trying to derive the Born rule via the Sikh formalism is an ongoing, very active research project. I say interlocking because they all feed into each other. And so let me just say a bit about the three projects. So the interpretation, by that we mean the question of how is quantum mechanics used? What do the symbols of the mathematical formalism mean? Are they related to reality? And if yes, how? And as, I think it was Michel's talk where he what was the term that he used for an interpretation that more or less says what things are not? You had a great adjective for that. Apophatic. Okay.
Like apophatic beyond.
So most of the answers that QBism gives under this here is, well, certain symbols are actually not directly representing reality. So mostly the quantum formalism is not representational, but there's still relations to reality, and that's a very important aspect of the QBist interpretation project. Secondly, ontology. Well, that's broader the question: what does quantum mechanics tell us about the world, the real world? And the one confusion one often has when talking to physicists is, well, physicists have often a very kind of narrow view of what that actually must mean. So what we are trying to do is be open-minded about the goals of physics. And so the question is, should physics give a description of the world as it is independently of us? And many physicists would say, well, that's just the goal of physics. That's what physics is. And by being open-minded about the goal of physics and about ontology means, well, not taking that as well, the only interesting question. So, for instance, there could be a fundamental role for agents. So you have the distinction between the third-person description of the world versus, well, it may be phenomenological approach, and it's probably clear that QBism leans towards a phenomenological approach where there's a fundamental role for the subject. And then reconstruction. So the key questions for reconstructions, and ultimately I think the motivation for reconstructions is really to ask, well, what's the right framework and what is the right set of axioms? So we all know there's many ways of doing it. There are different frameworks, there are different axioms. If you want to actually claim that one of these axioms tells you something about the world, well, you have to have a good reason for choosing that set of axioms. So that is one question that we are trying to address, and so the answers to these depend on both interpretation and ontology. This is one way in which these three projects are interlocking. And there's actually one motivation for taking interpretation and ontology seriously, because without these, you don't have any guidance of how to choose your axioms. And as we learned from Philipp, the question of what's a simple or what's a natural axiom is on the eye of the beholder. So without this extra guidance, we are basically you're lacking any foundation for this. And of course, the other way around, the answers to what's the right framework and what's the right set of axioms for reconstruction inform the interpretation and the ontology. So let me come basically to what would be the QBist strategy for tackling these interlocking questions. So the starting point, just as per my title, from the quantum formalism to QBism and back to the quantum formalism, the starting point is quantum mechanics for us. Quantum mechanics has been many times and probably the most successful physical theory ever. It's in an important sense given to us. It's an empirical theory. So for QBism, that's the starting point. The theory is nothing without an interpretation. So the next bit is interpretation. And then it turns out, kind of unfortunately, that you can think as hard as you like, but there is different ways of interpreting quantum mechanics. And a different or broadly consistent way of doing that. So in order to actually settle down or decide between these interpretations, you need to make extra choices. You need to commit to what I call key choices here. I'm going to tell you in a second what some of these key choices in QBism are. And well, you will, given that you start to formulate the construction framework and axioms as QBists have done, even though I don't think they're necessarily regarded as final, you derive the quantum formalism, which QBists have also done. Even that is not necessarily final because one can always must improve and come up with better ideas, better axioms, better derivations. We seek an ontology, and then since these things are overlooking, well, you just return to line 2 and basically start over and refine, because all these things are interdependent. So, as I said already, in John's talk, we are going to hear some more about the mathematical problems arising from the QBist interpretation. I think Matt is going to talk to some extent about the actual QBist reconstruction, or some. Where's Matt? Sorry, they're here. And about some interesting questions arising from that. So here are QBism's key. I mean, there are key choices for QBism. The first one is the world is local. But that means in Einstein's formulation, an object is directly influenced only by its immediate surroundings. And Einstein didn't see how physical laws could be formulated and tested without this assumption. And I think the basic idea is here: if you're in a lab and you want and you make experiments and you want to find out about the world and experiment, well, it must not be the case that somebody far away from you could actually, just by their actions, distant actions, change what's the case in your lab. That would be bad for the possibility of science. I think that's essentially what's meant by this phrase here. So but of course, that's a choice, right? So for instance, Bohrmian mechanics makes a different choice. The second one is, well, we can summarize like this: the universe is unfinished. The world allows for genuine freedom. Agents take decisions freely. So that's, again, I once heard a talk by Nicolas Gisin where he says, well, without free action by agents, again, science would be impossible. It's for me an important commitment, but again, I mean, there are others. For instance, many worlds makes a different choice, because there everything is basically encoded in one big wave function of the universe. And lastly, QBists are committed to seeking an ontology, as I already mentioned. So these key choices narrow down the interpretations you actually get. So the first one, locality, rules of Bohrmian mechanics. The second, an unfinished universe, rules of many worlds. The commitment to ontology means that QBism goes beyond GPTs. Here are some tenets in QBism. It's not a complete definition of sort of QBism. It's just 4 important tenets which are, I think, kind of crucial for well, yes, what I would want to say next. So here they are. The first one is that quantum states, unitaries or Hamiltonians, do not reflect properties of quantum systems, but are personal to the agent who assigns them. So states, but not just states, but also operations, unitaries, other quantum operations, Hamiltonians, they're all personal to the agents who assigns them. And that leads to interesting conceptual and technical problems, and I think John, as I said, will address some of that. The second one, there's actually one thing here is this is quite relevant for reconstructions, because it very much de-emphasizes the role of unitary evolution. The second one, a measurement, is not an observation that reveals a pre-existing property, but an action that an agent, Alice, takes freely on the world external to herself. So we wouldn't talk about observables, for instance, except in the limited technical sense, or observation. The outcome of a measurement is not objective and accessible in principle to anyone, but is personal to the agent who makes the measurement, which is possibly the most radical QBist tenet. So measurement outcomes are personal to the agent who performs the measurement. Whereas typically, very commonly, it's assumed that once there's a measurement outcome, anybody can go and check it. And the fourth one is the quantum formalism is not descriptive. So it's not representational, but it's normative. It guides agents in the decision-making. It answers the question, how should I act? So these are 4 tenets I would like to. So remember, the title of the talk is From the Quantum Formalism to QBism, Back to the Quantum Formalism. So I'm not going to say much about the Back to the Quantum Formalism. That's the actual reconstruction project. Matt is going to say something about that. But I would like to very much make the point in this talk that in order to actually choose the right starting point for your reconstruction, you really have to first interpret quantum mechanics. And so these tenets would be crucial in forming the starting point for any QBist reconstruction. And so what I want to do now briefly is tell you, give you some arguments which support every single one of these four tenets. The first one is the first one was quantum states and unitary, etc., are personal. So this follows quite directly from an argument by Einstein in a letter to Schrödinger from 1935. It is not the EPR paper. So that is an argument. It's often called steering, and it's very simple. Consider a maximally entangled state of 2 causally disconnected systems, A and B. And as is well known, this can be rewritten equivalently like this. So it's also a mixture of these two states, the eigenstates of the spin X operator. So now let's say I make a measurement on A, and then psi B is a conditional state after that measurement. Well, if my measurement is of the Z operator, in the Z basis, then my conditional state will be either 0 or 1. If my measurement is in the X basis, my conditional state will be either plus or minus. There are different states. Okay, so that's just a simple consequence of quantum formalism. So these are just repeating that statement here. So here comes a quote by Einstein in that argument. The real state of AB, the joint system, consists precisely of the real state of A and the real state of B, which 2 states have nothing to do with one another. The real state of B just cannot depend upon the kind of measurement I carry out on A. So that is his argument. Now, that can be, I mean, the implication in the paper that Carl Case and Chris and I wrote in 2002, we just take this argument and just rephrase it slightly. We assume locality, and this argument implies that psi B, the state at B, cannot be a function of the real state of B. So psi B does not, in that sense, does not reflect a real property of the system at B. And so that basically is still the key argument for taking quantum states as not reflecting properties, but to be personal.
Excuse me. You said it's an argument, but if I look at it, it's basically a statement. It's an assumption. It's something you want. It's not. I can't see an argument in favor of what is being said there.
Let's talk about that later. Okay, I have another argument. This time for the just bring back to my the second one is a measurement is not an observation that reveals a pre-existing property, but an action that an agent takes freely. So this is an absolutely beautiful argument that you cannot, measurements do not reveal pre-existing properties. So these are 18 vectors that form nine bases, and this is actually trivial to check. You can even just by looking at them, you see that they form bases. So there are 9 bases in a 4-dimensional Hilbert space, and there's also a perpendicular easy check. Every vector occurs exactly twice in the table. So this one is here and here is color coded. So this one is here and here, etc. These vectors have been invented by Cabello, Estebarranz, and Garcia Alcain for a 18-vector version of the Cauchy-Specker argument. Adam Stairs has combined this the Cauchy-Specker argument with locality considerations, which is what I'm going to do now. And Chris Fuchs has combined the Stairs argument with the Cabello et al. Construction, and Wikipedia is responsible for this nice figure here. So let's just introduce a little notation. So I have I use the letters A, B, C, D to denote these 4 basis vectors here. The second basis, this first is the same, so it must stay with A, and then comes E, F, G, etc. Okay, so this is just to simplify the notation here. And now I consider a bipartite system as before, and I consider maximally entangled state. And so that is just this the superposition here, A plus BB plus CC plus DD. And since these are all real coefficients here, well, that state is equal to the superposition of these 4 here and so on for every one of these columns here. So that's a kind of mathematical fact. So and now comes the argument. So assume that the 2 systems are causally disconnected. So again, there's locality and they're sort of far apart, let's say. I call them X and Y, the systems. I measure X in the first basis, and let's say you get outcome, I get outcome A, or any of the others. Get one of them, okay? Then I'm certain that it will get A again, because the state has AA in it. I will get A in a measurement of Y. So at the other location, the second system. When I well, actually, I screwed this up. So forget about the second basis here. So I'm certain that I will get A in a measurement of Y. I wish I could just erase this now, but this doesn't work here. So now comes the assumption I want to lead sort of ad absurdum. I assume that I believe the outcome A at Y, the one that I'm certain to obtain. I believe that outcome is already there, simply awaiting confirmation. So I believe in that sense the outcome is pre-existing. I just need to read it off because the outcome is already there, given that I'm certain to get it. Okay. So by locality, the fact if I believe that the outcome is already there, simply awaiting confirmation, well, that belief cannot depend on the measurement I do. So that means there will be exactly one pre-existing outcome for each of the 9 bases, because I could do any of these 9 measurements. But every vector appears in exactly 2 columns. So that would lead you to an even number of pre-existing outcomes, which is a contradiction to the 9 bases here. We'll just briefly show you how that contradiction arises. It's really very simple. So let's say I measure in the consider measurement in the first basis. I will get one of these outcomes. Let's say it's the first one. Then I am certain that if I did the second measurement, I also would get this outcome in the far system. Now I consider this measurement here, and let's say I get that outcome. Well, then I would be in a measurement of the far system. I would be certain to get this outcome in the measurement of the third basis, and this outcome in the measurement of the 7th basis, etc. So each time I make I consider a measurement, I will get a certainty. I will get a pre-existing outcome actually for 2 measurements, and then once well, if I have done this 4 times, I will basically have pre-existing outcomes for 8 of the bases. That leaves me with a 9th, one of them, and well, if I then make a choice there, I get a clash with some of the other one. So it's basically contradictory. So on that this leads to the following: even if I'm certain that I will experience a particular measurement outcome, I cannot assume that that outcome exists prior to my measurement action. Let's move on to the third tenet. Measurement outcomes are personal. So that follows if you take the Wigner's friend experiment, thought experiment seriously. So the Wigner's friend scenario, the conflict arises because, well, the friend has a measurement outcome, but Wigner from his viewpoint outside the lab, well, does not assign to quantum states that in which basically there's no definite outcome for the friend, and that, well, there's various ways of phrasing this, but in a sense, the difficulty arises from the assumption that it is an actual that the friend's measurement outcome is in principle out there in the world for anyone to check, and that's what leads to the contradiction. There's another aspect here which is troubling for QBists, which is the asymmetry of the situation here. I'm just going to show you that in a second. So basically, QBism rejects this very picture here, this asymmetric picture where there is Wigner here, and Wigner has a state for the lab, and this is basically in some sense lab and the friend, and this is in some sense tells you something that is the case, that is some factual information about the lab and the friend. Instead, we have the situation which you have in these 2 diagrams here. So this is the usual situation in which Wigner has a state assignment for lab and friend, and he takes an action on lab and friend. And this action refers to the consequences for himself upon taking this action on lab and friend. Now, That's all fine and no problem, because QBists would say, well, there's no issue here. Anything the friend does refers to his own experiences, which are personal to himself. What Wigner does refers to Wigner's experiences, and there's no conflict. Now, more recently, there were versions of Wigner's friend by Baumann and Bruckner and by Frauchiger and Wenner, and they lead to sort of complications of the issue. Because they consider, well, what are the friends' predictions for Wigner's outcomes? And they're complex but sort of interesting considerations. And QBism gets rid of these complications by a simple and very straightforward move. QBism restores the symmetry between Wigner and the friend. If an agent is an entity that in principle can take actions freely, or not in principle, that takes actions freely on the world external to himself, well, we need to give the friend that freedom, respecting one's fellow agent. So if you want to look at the whole situation from the friend's perspective, the friend cannot just assume Wigner's viewpoint and make it his own. The friend has to treat the world outside of himself, including the lab, the particle Wigner, as a big system outside of part of his external world, apply quantum mechanics to that big system, which is difficult and nobody has done it, but then nobody has done that thing either. That restores the symmetry between friend and Wigner, restores the autonomy and freedom of the friend as a quantum agent. The normative character of the Born rule. So here's the Born rule. Rho is probabilities are given by trace times PVM element. If you're uncomfortable with that formalism, replace this by a projector on a pure state and this by a von Neumann projector, and they have the Born rule in the more the older form. A common reading of this is that Rho, this object here, is determined by a preparation procedure. This operator here, the POVM element, or the whole POVM, the set of EI, is determined by the measurement apparatus, and then PI are the correct probabilities implied by the Born rule. So that's the standard, or it's a very common reading of the meaning of this formula. Now, QBist normative reading is different. In QBism, Rho expresses the agent's degrees of belief. Similarly, the PVM expresses the agent's degrees of belief, and the PI also expresses the agent's degrees of belief. None of these is primary. So the only thing the Born rule does is it stipulates that you should strive for consistency. You should basically, the normative character of this rule is that you should strive to satisfy it. So your state assignments, your PVM assignments, and your probabilities need to fit together in such a way that the Born rule is satisfied. And so the Born rule is a consistency, it's a normative consistency requirement on the agent's decision making. It's not a rule that allows you to derive probabilities. And that's one point where it's very clear that we are not talking about Bayesianism here. Okay, so I'll go back to my earlier slide about QBist strategy. So this is how QBism views, reconstruction, really. Reconstruction doesn't come first or last. What comes first is quantum mechanics. From quantum mechanics, we get, we need to interpret quantum mechanics. In order to do this, we need to commit to some key choices. That allows us to formulate reconstruction frameworks and axioms. We derive the quantum formalism, we seek an ontology, and we go back to the beginning to define and to actually make the whole thing consistent and satisfactory, and learn as much as we can about quantum mechanics and the world. Thank you.
Okay, thanks so much for the talk. So we have time for questions. Yeah.
Maybe I'm missing something very obvious. Like I probably am. But why does speaking in ontology go beyond GPTs?
Oh, GPTs don't commit to ontology.
Okay. But does it preclude that you could use them as a tool to search for one?
No.
Okay. Why is that?
Sorry, why is what? Excuse me.
Why does using GPTs as a tool for reconstructing quantum mechanics preclude the idea that you can use that? Or why did GPT preclude being used as a tool to seek for some kind of ontological story? I don't understand.
All I said is that QBism, in that it's seeking ontology, goes beyond the project that you have in the reconstruction problems, the reconstruction project started from GPTs. Yes.
Thanks for the nice talk. Since you just listed the key choices here, I just wonder how you think of them in the sense of their necessity. So do you think if you could drop or weaken some of them and still have a well-defined project, similar to QBism, or are you kind of sure that they're all in its form like necessary to make sense of the world in the way you would like to?
Yes, the key choices. Well, necessary is interesting because, as I said, Bohmians and many worlders would not regard them as necessary. So in that sense, they're not necessary. But actually, I wouldn't want to weaken them because I think for me, they're personal choices.
Maybe a quick follow-up on that. So imagine an agent that just, severely disabled, cannot move and do anything, do any actions. You could still think of taking a kind of beta-bilitarian or Bayesian view, perhaps, on the quantum state. So I wonder, is like technically this notion of action that you're really able to act on the world, is that really necessary for?
Well, that's a good question. I think I would defend that because in such an extreme case, if an agent cannot even by just winking or any way of acting, cannot act on the world in the slightest way, then, well, I don't know. I don't know what the implications there are, but I would say that, even in extreme cases, unless you're totally locked in, that's what you mean, you're totally locked in. Well, if not, you can always act. You can always blink with an eye or establish some communication and act via somebody else. So,
Thank you. Do we have any questions? Yeah, thanks a lot. I think I understand QBism a bit better now, or at least I think that I have a better grasp on the claim that there is some normative aspect in QBism. I still wonder whether that requirement, consistency, what you take to be, the normative aspect, is personal or not to an agent. Since the outcomes are personal, is that, normativity also personal, or is it, intersubjective somehow?
Well, that's very interesting. I think it really comes back to the discussion that we had and you had with Chris after your talk, right? Because it's this question. We would maintain that you can have actually something objective. Maybe there's something even which you could regard as a property of the world that you should use this to guide your act. So you should use the Born rule to guide your actions, even though this is a rule that just well, a normative rule that connects your beliefs. So I like to think of this as something objective, even something physical, something about the world. Now, I have no idea, of course, whether from a logician standpoint, this actually is coherent. I would think, I mean, it's different. It's different from other physical laws, for instance, very different. I don't think it's incoherent. I think it's, I mean, it's a key plank of QBism. QBism solves all kinds of interpretational problems by doing that. So I think there's some strong evidence that this is a sensible move.
Thank you very much for this clear picture about QBism. In one of your slides, you post that QBism leads to participatory realism and not to intrusive realism. And then the fourth tenet of QBism was the normative aspect of realism. And so my question is there not a conflict between these two views? Because if you are participatory realist, you are in some way and to some extent realist. And if you are in some way and to some extent realist, you should say that the formalism describes reality in some way and to some extent.
So can you just say the last sentence again?
So if you are realist in some way and to some extent, so the theory should describe reality in some way and to some extent. And so, at least in some way and to some extent, that theory is descriptive. It's not totally normative. Yeah,
okay. I mean, the idea of acting on the world, the actions have consequences for myself. So it's not, I mean, that's one bit I think I would like to turn out. These are real consequences for me. In terms of realism, so I'd say the theory is not representational. So the objects of the theory, unitary operators, wave functions, they don't represent anything in the world. But the structural aspects, and again, the Born rule of foremost, I would regard them as part of reality, if you like. Certainly as part of, as a feature of the world, that this is the best way to actually reason and the best way to act. So in that sense, you could call it, I mean, this participatory realism, in the sense that there is the belief there is a real world, and the agents act in this real world, and there are consequences for the action. So that is, I mean, a picture that commits to the existence of a world, of an external world, and it's and you might certainly has also some similarities to structural realism, where what's real is the structures and the rules of how things fit together or should fit together.
Okay.
Thank you. Thanks for your instructive presentation. I have a question about the tenet number 3. I think it's the next slide. Here.
Mm-hmm.
Just for clarification, I have difficulties to imagine the content of this tenet in a rather, let's say, complicated situation. Let's say at CERN, people do some research. There are about 160 technicians who work on setting up the device. There are 42 computer programmers who are making sure that the software records tracks correctly. There are 7 scientists who actually think about what should be done at what energies, etc. And so my question is, who makes the measurement? And the outcome, which is found, I'm not exactly sure what the outcome is, maybe a trace on a computer screen somewhere. To whom belongs this hard to identify outcome? So I'm just wondering about a complex experiment with many people, many agents involved. How do I think about this idea of allocating an outcome to somehow an individual?
First of all, there's no fact of the matter. So it's not the case that one particular sort of it's true that individual X is the agent and the others aren't. So there's no external fact of the matter. The other one is that if, let's say, if I am the leader of the project, and I'm the one that actually sets this all up, guides the science jobs, etc. I have different ways of dealing with this situation. I could, in the extreme, could just regard everybody and the entire team as basically an extension of myself, and I say they are basically of the apparatus, and they provide me with the outcome in the end. That's one way of doing it, a consistent way of doing it. Or I regard the thing as a team where sort of as a whole team of agents. Some make measurements, and then I regard them as experts on whose results I use to inform my own state assignments and my own judgments. There's a third way of doing it. You could regard a whole team of physicists and programmers as one agent, because they would have just one utility function. They would make decisions jointly as a team. They actually, if the experiment fails, they suffer jointly, etc. If it succeeds, they share the glory. So there's various ways of dealing with the situation. But most importantly, it's not a matter of fact. Of objective fact, which is the correct way of looking at this.
Okay. I'm trying to understand your sort of negative qualification that the outcome is not objective and accessible in principle to anyone. But now if you introduce a team as an agent, then you would somehow think that every member of the team somehow is capable of knowing this outcome. And therefore, it's, in a sense, objective, at least among this group of people, and accessible to more than.
I should have said is not accessible to other agents, because if I treat the team as one agent, then that would take care of that objection, I think.
Yeah, but I would still, as a member of the team, I would still maintain my individuality and say, I can see that outcome and it belongs to me.
You certainly could. I mean, you certainly could analyze it in this way as one team member. Definitely, yes.
Thank you.
The key point is there is one agent. And, you said that they have 162 times 2.
Yeah, I think
10 tones. So the agent with many tones. So there's one agent, and then put a circle around it. The outcome is real for that agent, but it may not be real for you. You're not inside the circle. That's the idea.
Well, let's just make the circle and the taxpayers.
Whatever is the decision maker, the person who writes down a utility function and a probability assignment is the agent, whatever that entity is.
Just clarification, if I'm a member of the team, so can I treat the team as an agent in addition to treat myself as an agent, as a member of the team? And can they disagree? Can I disagree with the team and yet still be part of both in some sense? Like maybe there's a consensus that I disagree with, but everyone else is for it. Does that make sense?
It's maybe worth thinking about, but I don't have a prepared answer to that question.
Johannes?
Yeah, thanks for the fascinating talk and for this nice overview over QBism. I have a comment and a question. My comment is on your first key choice. If you go back one slide, maybe. I'm not sure it's fair to say that your first key choice really rules out pilot wave theory. Because, of course, there's an ambiguity towards what we mean by an object in this sentence here. And in the context of QBism, the variables by which Bohr mechanics is non-local, they simply don't exist, right? So if it's in terms of what observers have access to and their beliefs, then also pilot wave theory would say that the theory is local. You don't have signaling, yeah.
Is that I mean, you can make it work, but you need something that's something is called fine tuning. It's you see if you describe this to people who just hear about non-locality or sort of entanglement for the first time. I mean, at the time, I think people were hoping to use this for communication between submarines. You don't have to explain you actually cannot use it for signaling. The theory is just so precisely fine-tuned that, well, the hidden variables, they're instantaneously affected, but nothing observable is. And yes, you can do this, but I think the argument against it, namely say that fine-tuning is implausible, I think is a strong one, at least in my mind.
Unless we maybe have independent reasons for why we arrive at a finely tuned universe by some dynamical equilibrium, like yes. Valentini and stuff like that. And I also had a question which was on the weakness-friend scenario that you mentioned. I wasn't entirely convinced that there's a problem with the fact that the inside friend is not entitled to argue about weakness predictions because it wouldn't be a free choice or something like that. I mean, we do this all the time, right? If I perform an experiment in this room and I can ask myself, if someone walks into this room, what will they see? Why is that problematic? Because your argument was that the friend cannot argue about the predictions of weakness.
Oh, no. Okay. The friend cannot make Wegener's cannot make Wegener's state assignment of himself. So basically, Wegener is a state assignment of the friend. And so I'm saying that the friend cannot make use of Wegener's state assignment to himself in order to inform his predictions, because that is ultimately it's certainly self-contradictory if you think of probabilities and states in terms of decision making, because you cannot coherently assign bet on your own decisions and choices.
So I can ask myself, if someone walks into this room, what will they see given their knowledge, hypothetically? It's all what happens here. And they use quantum theory, and I can argue what they could do and could not do.
Well, I think my answer stands. If that actually if the judgment about what the other one would see actually relies on making use of probabilities that the other agent assigns to my actions, then the whole thing becomes you can no longer apply the formalism consistently to do that in that case. So that I think then is still the case. And this is in order to derive these paradoxes, you always do that.
Maybe last question, and this works because of your freedom of choices assumption. If you don't have that, then you would say you couldn't make assumptions about what Wegener predicts about myself?
I think that's true, yes.
Okay.
So I have a question, depending in the, or again in the first key point that you mentioned on locality and the fear by Einstein that without that you cannot really say anything about the world. I'm not sure how important is it that this locality is understood in spatial or spatial temporal terms. Because I think the fear by Einstein is like, okay, if we're trying to understand what is happening with this system, I have to be, it could be in principle influenced by anything. Then it's truly impossible to say anything, to give physical laws. But and then in that sense, a space-like separation it could be understood as the most efficient way of isolation we have. But I wonder if it is really a necessary condition that we have that. And let me put a metaphor, no? Like I don't know, some few centuries ago in planet Earth, the communications and the transmission of matter and information was much more limited, no? By what you could run by horse or what you could send with flying pigeons. Now these limits don't exist anymore. Information is instantaneous and flying can get you anywhere in a few hours. But still we can say tons of things about the world and we can be sure that certain influences are not going to happen. I mean, I'm sure no one in South Africa will close that window now. There is still rules and we can still talk rules, plenty of rules. So I wonder whether QBism depends strictly on this spatial notion of being able to talk about locally in the sense of somehow isolated systems, how much, or whether it could be weakened, and if it could be weakened, whether it would still rule out Bohmian mechanics or whether it would only rule out superdeterminism. That's
I just don't know the answer to that.
Okay, Julian, do you have that? No? Okay, perfect. Then let's thank again our speaker.